Okay, so this video looks at all the different things I can ask you that have to do with function notation. So there's all kinds of things we can plug in and things like that, but there's different ways that I can ask it. So starting really basic, if these are the three function rules that I have, I could just say something like find f of -2. Okay, so what that means is I'm just going to go to f's function right here, and wherever I see an x, I'm putting a -2. You can put this in your calculator, do it in your head, by hand, however you want. This should give you 4 + 2 or 6. So that's the y value that goes with -2 if you are looking at f of x. Okay, so that's really basic. I could ask you to do something like find g of a + 3. Okay, so again, I go to g. Don't let it freak you out that there's algebra here. It's the same concept. Wherever the x is, I'm putting, in this case, a + 3. So 4 times a + 3 minus 1. I can distribute and then combine like terms. So when I combine the 12 and the 1, I just get 4a + 11. So if you're plugging in something that's not just a number, like that first example, then you're going to get something that has a variable in it. So in our case, 4a + 11. It's okay to not get a numerical answer. We can also do operations with more than one function. So for example, I could ask you to find g plus h of x. Okay, so all this means is that I'm going to be finding g of x and adding it to h of x. Notice we didn't give us anything to actually plug in. We're just using plain old x, so that means I don't have to change anything about these functions. So I'm just going to write down g of x, which is 4x minus 1. I think it's a good habit to keep it in parentheses because sometimes we have to distribute and things like that. And h of x I'm just going to keep as -2x. So now all I have to do is just combine like terms. So I can combine 4x and -2x. That's going to make +2x. And -1 has nobody to go with, so that's just going to be attached to our answer. And that's it. Okay. Another example of an operation I could ask, I could say something like find f times g at 4. Okay, so same idea as before, but I'm actually giving you a number to plug in this time. So you're going to find f of 4 and multiply it by whatever g of 4 is. So it's really you're doing two separate evaluating and then multiplying or doing whatever operations in between. So in this case, again, I'm going to try to keep everything in parentheses. I'm going to square 4 and add 2 because that's f's rule. And that is going to get multiplied by 4 times 4 minus 1. So you could probably throw this all in your calculator right from here, but you should get 18 times 15, which gives us 270. So again, going back and forth between when this is just an x or some other kind of algebra, you're not going to get a plain old number. But if it is, like in this example, all we plugged in was 4, we are getting a numerical answer. So you want to kind of make sure you're understanding what should I be getting. Okay, so those are some operations, some evaluating. I can also ask you to find a composition of functions. So if you remember from class, composition uses this hollow looking dot. So let's say I've asked you to find f composed with g at -3. Okay, so this is the same as writing f of g of -3. Kind of hard to see my negative there. So this is really saying whatever your answer is for g of -3, that's going to get plugged into f. So first I need to find out what g of -3 is. So again, I'm plugging in -3 where x is in g's rule, and this gives me -13. So now I'm going to go take that answer and put it into f. So f of -13, make sure you're putting the -13 in parentheses because it's going to make a difference if you put this in your calculator. Okay, so that should give me, I believe, 171. So that's my final answer to the composition. We could also do compositions that don't necessarily get evaluated at numbers, just like everything else. So I could say, no, let's not do f again. Let's do g composed with h at x. So again, same concept. If you see this notation, this is the same as asking g of h of x. So again, find what's on the inside first, because then that answer is going to get plugged into the next function. So in this case, there's not really much I can do. H of x is just going to stay who it is because there's nothing to plug in. So now I take this answer and I plug it into g. So I'm putting -2x where the x is in the function and just simplifying. So that's going to give me -8x minus 1. And so that would be the answer to the full composition. Okay, finally, another function notational thing I can ask you is I can ask you to do something that looks like this. I might say find the inverse. So if you see that little -1, that means inverse. And we learned how to do this in class. It's actually really pretty easy to do. You just have to be able to recognize it and know what you're being asked. So if you're asked to find the inverse of a function, you're going to start by writing out that function. If you remember, we talked about this the other day, that an inverse of a function takes all of the x and y values and swaps them. So first, I don't even see a y, so let me rewrite. F of x is really just a fancy way to say y. So now I'm actually going to swap the x and the y. So I'm going to rewrite this as x equals y squared plus 2. So I've done what I'm supposed to. In an inverse, remember, the x and the y switch. Now I'm just going to solve for y, because that's typically how functions are written. So I'm going to subtract 2. This gives me x minus 2. To undo a square, I know I need the square root. So I'm going to come over to the left here because I'm running out of space. So the square root of x minus 2 is now y. So I've isolated y. I want to go back and just write that using the notation I was originally asked to do. So that means that the inverse function of f of x, is the square root of x minus 2. So this would be the proper way to write the inverse that we just found. Okay, so kind of continuing on with inverses, because I know on that worksheet they're combined. This is another really common question we get asked with inverses. So the reason we do this all at once is because one really easy way to check if two functions are inverses is to actually find their composition. So if you wanted to answer this question algebraically, this is how we would do it. You can either do f composed with g or vice versa. The order does not matter. Okay, so if we were doing this, this is really f of g of x. So like we said before, find what's on the inside first. This is pretty easy, no work to do, just writing out what g is. It's not the same as before. I changed the functions on this page. So now I'm going to take that and plug it into f. So I'm finding f of x minus 5 over 2. So if I plug this in, f's rule is 2x plus 5, so I'm doing 2 parentheses x minus 5 over 2 plus 5. Okay, well, what's kind of nice here, the 2's cancel. I'm left with x minus 5 plus 5. And, oh, those cancel too. I'm left with just x. That's how you know that two functions are inverses. If when you compose them, you get x. That, because they're inverses, they're undoing each other. So you could just write something as simple as, these functions are inverses. Because when composed, their answer is x. Something simple like that. So if you don't want to do this algebraically, the other thing you can do that I can't show you because I can't pull up the calculator, you could graph these two functions and show that one is the graph of one is flipped over the line y equals x as compared to the other. Or you could look at the x and y's in the table function of the calculator and see that all of the x and y values are swapped. So you really could do this a couple of different ways, but I can't show you the calculator here, so I showed you the algebraic way.